Hello everyone, welcome to Huawei Cloud Tech Talk. Today I'd like to introduce GeminiDB, Huawei Cloud's newest multimodal database service. GeminiDB can process and integrate several types of data, including key value, document, wide table, and time series data. We named this service Gemini, the twins, as is the astrological sign associated with adaptability, variability, and communication. GeminiDB is a NoSQL database that uses cloud-native distributed framework that decouples storage and compute. It comes with APIs compatible with Redis, DynamoDB, Cassandra, HBase, and InfluxDB. GeminiDB delivers high concurrency, low latency, high availability, and high scalability, all at a low price point. It's perfect for workloads in a number of different sectors, including the gaming, e-commerce, advertising, social networking, IoV, and IoT sectors. The GeminiDB Redis API is compatible with traditional Redis databases, so applications can be migrated to GeminiDB without refactoring, and it can handle up to 10 million QPS. Data is kept in persistent storage on GeminiDB Redis instances. 3-copy storage helps protect against data degradation. Your data is automatically moved between hot and cold storage as needed, with an average sub-1 millisecond latency and a P99 latency under 2 milliseconds. You can scale compute and storage resources independently, so data does not need to be copied when compute nodes are added. This allows you to expand storage to hundreds of terabytes without any impact on services. In addition, GeminiDB uses both logical and physical compression to achieve an impressive 4:1 compression ratio. All of this makes GeminiDB a cost-effective solution for storing key value data. GeminiDB DynamoDB API compatible comes with enterprise-grade features such as global tables, point-in-time restoration, and DynamoDB streams. You can use DRS to migrate data from DynamoDB to GeminiDB without refactoring. GeminiDB provides 40% higher read-only performance and 10 times higher write-only performance at the same fixed monthly expenditure. The GeminiDB Cassandra API is compatible with Cassandra and can lower I/O latency and increase throughput. Self-managed Cassandra clusters often have garbage collection issues. It's hard to strike a balance between data consistency and performance. Identifying big keys and hotkeys and maintaining clusters is difficult. And so cluster scaling can be a long and complex process. But with GeminiDB Cassandra API, you have a variety of different backup options that allow services on a faulty node to be taken over and restored in seconds. Remote multi-active disaster recovery can increase availability for up to 99.995%. GeminiDB Cassandra API also comes with a Lucene search engine with a key storage value engine to provide powerful search and indexing. This makes it capable of text search, fuzzy search, and statistics analysis. GeminiDB HBase API is compatible with HBase and can address a number of pain points that plague open source HBase. The GeminiDB HBase API is ideal for internet applications and real-time queries of massive volumes of data. Open source HBase is also difficult to maintain due to its complex architecture. Restoring single faulty nodes can take minutes, while restoring a large-scale faulty cluster can take hours. GeminiDB's cloud-native decoupled storage and compute architecture allows it to deliver 20 times faster MTTR for single nodes than open source HBase. It also makes it possible to complete a failover within seconds. GeminiDB HBase API delivers 5 times higher single-row read performance, 7 times higher single-row write performance, and 9 times higher range read performance than open source HBase. GeminiDB HBase API needs 1/10 the storage of open source HBase using a default compression algorithm, and it can get by on 1/3 of that storage when using Snappy. GeminiDB Influx API is compatible with InfluxDB, but it's also a more cost-effective, high availability option. You can add compute nodes in minutes and scale up storage in just seconds. GeminiDB Influx API uses an in-house adaptive compression algorithm that reduces the traditional HBase storage overhead by 10%. It also segregates hot and cold time series data, which can bring your storage costs to as little as 1/20th of what it would be with a relational database. In terms of write performance, 1 billion records can be distributed to each compute node in a cluster. A vectorized query engine returns data in each iteration, which significantly reduces the extra overhead. GeminiDB Influx API provides optimized solutions for time series data thanks to its efficient data compression, separate storage of hot and cold data, and high throughput clusters. It's perfect for writing and querying massive amounts of data in large-scale O&M monitoring and IoT scenarios. To sum up, GeminiDB is a distributed, multimodal, NoSQL database service with decoupled storage and compute architecture. It has 5 engines compatible with mainstream NoSQL APIs for DynamoDB, Redis, and InfluxDB. These APIs are GeminiDB Redis API, GeminiDB Cassandra API, GeminiDB DynamoDB API compatible, GeminiDB HBase, and GeminiDB Influx API. GeminiDB delivers low-cost I/O performance, making it ideal for IoT, internet, and gaming applications.